Hey everybody, welcome to the Hump Day Hot Tip for this week. Over the last few weeks, we've been looking at capping off shapes. We started with a simple circle, then we did something more complex. We did a squircle, kind of a squared off extrusion, and then we did an elliptical extrusion to show you something slightly more complex. And today we're doing a weird shape. We're doing something that's not really anything in particular. We've got some circles on either ends, we got some weird stuff in between, and we could talk about various ways of achieving this. Now, we've talked about the fact that we want to use the simplest possible geometrical method. We can do an extrude, revolve, sweep, loft, boundary, or a filled surface, and those are roughly in order of complexity. Now, in this case, there's really only one tool that can do all of this in one big surface, and that's the filled surface. So if I select that tool, and I want to select this entire boundary, I can click on each element of this boundary one by one to get there, and that'll work. Or a quicker way to do that would be to cancel this. Let's go run this again. Let's right-click on this and just say select tangency down here. That'll give us the entire thing. Or if I didn't have tangency in that case, I could right-click and go down to select open loop, and that would give me the whole thing as well. So those are all available to you. Now, underneath in the edge settings, we're going to set this to tangent continuity. And unfortunately, first let's select all of these. We've got to select them first. There we go. We'll set those all to tangent and hit OK. Now, this is not going to give us much control, but it will work. So if I hit OK, we do get a result that actually is not horrible. You know, this looks pretty close to what a lot of people would want. Unfortunately, what I don't like about it is it's kind of short over here and kind of tall over here, and that's just kind of because of the radius of the circles at either end. And also, if we turn on our curvature, yeah, it's not too bad, actually. That's surprisingly reasonable. It's actually not terrible at all. And if we turn on our zebra stripes, this is probably going to be tangent continuity, but only just. It'll be just barely continuous. And we do get some little lumps. You can see we've got sort of a little bump going on here, some kind of little dip in our surface. Okay, so that is one method, and it's okay. But I don't know, to be honest, it just doesn't look very clean. To me as an industrial designer, this looks a little bit like a bar of soap. Not as defined as I would like to be, not as crisp. And the only way to do this other than that is piece by piece. We're not going to be able to do it in one big surface. So if I were doing this on my own, here's the method I would probably use in a real-world scenario. I would first start with my revolved surfaces. Those are the simplest, of course. So I've gone ahead and created a curve here to create a revolved surface. And I'll run another revolved surface at the other end and hit OK. And both of those work just fine, but we're going to need to create this middle piece, and we can do that using a loft. So let's first add a couple of planes. I'll grab my plane tool. I'm going to go through this point, and this point, and this point. Whoop, wrong one. Let's delete that. Let's clear this out and select this point. There we go. And hit OK. Then we'll grab our plane tool again, and I'm going to pick on this point and this point very carefully, as well as this point. There we go. And hit OK. And now we can do some trimming. Let's grab our trim surface tool. The plane will be my tool. I'll cut off that surface. So we're left just with that bit of it. Do my trim surface again. Keep this bit. And hide those planes, because we don't need them anymore. Now we have an extremely clean result that we know is absolutely perfect, and that the height of these two match because I made the sketches match. And all we have to do is finish this off with a simple loft. So let's grab our loft tool. I'm going to loft from here to here. There we go. And now we just have to make it follow. So let's go to the guide curves, and we know that this is one guide curve. We definitely want to follow that. Then we have to follow this other thing. Now, those of you who know about them may have tried composite curves in the past to combine edges like this together into a single string. That's a terrible idea. Never use composite curves. In fact, avoid them like some terrible disease. You don't want them. Okay, so let's right-click on this edge and say Selection Manager. And from there, I can actually just click on this little multi-mouse thing here, and I'm just going to click 1, 2, 3, because that's all I want is those 3, and hit OK. It'll combine all 3 of those for me and use them as an input for our loft. And that, my friends, is perfect. Now, let's just make sure that for both of these, that we're setting them to tangency to face on both sides, just so that we get clean tangency across there. And actually, for the start and end constraints, we kind of want tangency to face as well, even though it might be overkill. We might not need that. Hit OK, and that should look pretty decent. All right, actually, that doesn't look decent. Look down here. We've got some twisting starting to happen here in the middle. Oh, no! Well, let's turn on the curvature so you can see it. See how it's kind of twisting under itself down there on that side? Or we'll turn on curvature graph. See, we're getting this weird kind of redness down here where it's really inverting. There's a big curvature inflection there. Ugh, yucky. Yucky, yucky. So like I was saying, if we remove some of these constraints on here, things will tend to work better. Let's put these back to none on both sides and hit OK and see what that does. Much, much better. And in fact, we're getting pretty close to tangency without having it explicitly defined here. So if I turn on my zebras, they're close on the edges. In the middle, they're not so close. All right, so let's look again. Let's see if we can solve this. Let's turn this stuff off. Go back here. We do need to have those tangency constraints on either side, tangency to face on both sides. And let's try turning off our tangency down here at the bottom instead. So that could help as well. Again, the more constraints you put on the surface, the more likely you are to have problems. All right, so we're still getting that weirdness, though, where it inverts on itself down here at the bottom. So it seems like a loft surface isn't working for us. So we'll have to try something else. Let's go to the boundary surface, which will just use a different algorithm. It works pretty much the same from the user standpoint, but it'll give us a different result, so we might as well try it and see if it works better. Once again, I'll use my selection manager to select all 3 of these edges. Hit OK. That connects it up. We'll do tangency to face on both sides here. And just for the sake of a similar comparison, let's do tangency on both sides here as well. And hit OK. And that result is looking much, much better than what the loft was giving us. So let's turn on our zebra. It's tangent. It's not curvature, but it's tangent, and that's okay. Let's turn on our curvature. We've got a little bit of a dip here, but, you know, it's manageable. It's not too terrible. So we can go back here and edit that surface. Let's see if we can massage out that dip a little bit. I'll go up here to this guy, and let's just turn up its tangent influence so that it really pushes that surface harder right there. Sometimes that'll create distortions around the corners, like right here. You got to watch for that. But you can see that it's, in this case, given us a better result that's actually pretty decent. So this, folks, is probably about as well as we're going to be able to do here in SOLIDWORKS, and the result is pretty decent. If we're looking at this in real-world terms rather than analytical terms, it's pretty good, you know, and this is a very nicely controllable surface. All right, so that is the hot tip for this week. If you need to do a complex cap like this one, you're probably going to need to use multiple sections to get the cleanest possible result. Have a great week, and next week, let's do something different, all right? I'll talk to you later. See ya.